Combustion reactions are somewhat familiar to most students. However, what combustion actually is usually somewhat less familiar. When we think of something combusting, we tend to think of something burning. Now, you probably remember when you were younger that you learned that in order for a candle to continue burning, it requires oxygen in the air. If you turn a glass upside down over the candle will go out because the oxygen in the air is all used up. Then the fire can no longer go on. Because the word combustion or burning combines with oxygen gas. Now, combustion can happen fast, like an explosion, or when we're burning gasoline or natural gas or wood. However, combustion can also be a relatively slow process. And sometimes a combustion reaction isn't what we would necessarily expect. We're going to look at two major kinds of combustion reactions. The first one we're going to look at is combustion of a metal. Now, we don't usually think of metals as burning. However, some of you may be familiar with the magnesium flares. That's the road flares that we use to signal if there's an accident. You'll see them burning on the side of the road. What's actually happening in that is that the element magnesium is actually burning, meaning that it's going to combine with oxygen gas. Well, what actually is the result or product of this particular reaction? Anytime you're going to combust a metal, your product is going to be the oxide of your metal. So we're combusting magnesium, so our products are magnesium oxide. That is an ionic compound. So we know it's made out of magnesium and oxygen. And we'll double check our oxidation numbers to make sure that we're writing the formula correctly. If we look at magnesium, magnesium is positive 2. When we look up oxygen, oxygen is negative 2. So they cancel each other out, so that our formula is just Mg and O. So what happens when we combust a metal like strontium? Let's choose a different metal. Let's do sodium. So again, the word combustion means we're going to have to add the oxygen. We're going to make the oxide of the metal, so we're going to make sodium oxide. It's a simple ionic compound made of sodium and oxygen. Oxidation number of sodium when it becomes an ion is positive 1. Oxide's negative 2. So it's Na2O. Okay, the other type we're going to talk about is combustion of fuels. Most fuels are what we call hydrocarbons. Hydrocarbons are made of the element hydrogen, hydro, and carbon, C, in some format. Though the name is somewhat misleading, unfortunately, because when we see the formulas written for hydrocarbons, we always see those elements written in reverse order. Carbon, and then hydrogen. And then carbon will have some type of subscript, and the hydrogen will have some type of a subscript. So hydrocarbons are basically compounds that are composed either entirely of carbon and hydrogen or almost completely out of carbon and hydrogen. You will see some oxygen appear occasionally. Those are usually alcohols. Alcohols will burn quite nicely. Okay, if you've ever seen, gone to a restaurant and see them make Cherries Jubilee or Bananas Foster, where they pour alcohol on top of a dessert and they light it. It burns off the alcohol and leaves some of the flavoring behind, but alcohols burn rather well. Okay, the pattern for a hydrocarbon burning looks different. Now we're still going to have to combine the oxygen. You'll have to remember when you see combusting a hydrocarbon, whatever the formula is here, you simply have to add oxygen. Now what happens when hydrocarbons burn is that the carbons, the bonds between the carbon and the hydrogens are broken in the hydrocarbon. The carbons will they'll covalently bond to the oxygen molecules, and they'll form the compound CO2. The hydrogen atoms will also covalently bond to oxygen, and they will produce water. So regardless of what the subscripts are in the hydrocarbon, you'll always make carbon dioxide and water. Okay, students think this just feels too simple, but that's exactly what you need to do. Alright, so let's look at an example. C6H6. This is called benzene. Hey, if I say what does it look like when benzene combusts, you'll have to add the oxygen. You always have to add the oxygen on the reactant side. Hey, just remember, the carbon combines with some oxygen and makes CO2. The hydrogen will combine with oxygen and make H2O. Now, you may ask yourself, well, there's 6 carbons and only 1 over here. These are unbalanced or skeletal equations. So we would have to balance them if we really wanted to see, well, where are the 6 carbons? Well, obviously we're going to make 6 molecules of carbon dioxide. Okay? And 6 of those would mean 3. Okay? And we'd have to make sure they get all balanced out. So regardless of the formula of the hydrocarbon, this is methane, like methane gas, the same 2 products are always created when you combust a hydrocarbon. The only real difference between burning different fuels is that you make different amounts of carbon dioxide and different amounts of water. Okay? Methane is used in vehicles that say they run on compressed natural gas, and they make a lot less carbon dioxide than octane, which is C8H18, which is a high-performance additive in gasoline mixtures for car tanks. They produce a lot more energy when they burn, but they make a lot more carbon dioxide for the atmosphere. So that's one reason that people are looking at methane, compressed natural gas, as an alternative fuel. Okay, so that's it for combustion. The last section of this video is going to we're going to go briefly back over the 5 major types of chemical reactions and discuss again how to identify which of the 5 major types a particular reaction falls into. Okay, so decomposition. Out of a list of chemical reactions, how do you identify a decomposition reaction? Okay, there it would be 1 reactant. So anytime you see a whole bunch of different chemical equations, but there's only one compound to the left of the arrow, it is a decomposition reaction. Remember, synthesis reactions are kind of the opposite, if you will, of decomposition. They have one product. So if you see any chemical equation and there's a single compound to the right of the arrow, that will be one product. So how do you pick out the single displacement? These can be identified as an element plus a compound, and that produces a different element and a different compound. Double displacement reactions can be quickly identified because you'll see two compounds on the left and two compounds on the right. And lastly, the one we just learned, combustion reactants, O2, will be on the left side of the arrow. Okay, that's really important. Just because if you see O2 on the right side of the arrow, that's not combustion. That's something else. O2 has to be a reactant in order for it to be combustion. Okay, so that's just a general kind of quick way to go through a list of reactions and decide which of the 5 types is each reaction. What 5 does it belong to?